Hello, we are here to do assignment on machine learning and artificial intelligence. This is our assessment number 3 and we are going to predict earthquake magnitude. This is a comprehensive data analysis and we are group number 39 and we have 3 group members. I am Newton Timalsina and my other 2 friends are Saugat, Pokhrel and Rishi Baskota. As you know, earthquakes are natural disasters that can have devastating consequences including loss of lives and property damage. It is crucial to understand the nature of earthquake as to mitigate their impact and provide early warnings to affected population. This project aims to explore earthquake data, especially focusing on predicting earthquake magnitude based on various attributes that is available to us. The attributes can be latitude, longitude, and we will discuss about attributes later. Regarding dataset description, we have downloaded dataset from kaggle.com. We have different attributes of the dataset columns such as time, location, latitude, longitude, depth, magnitude source, etc. By analyzing this dataset, we can gain deeper understanding of the earthquake patterns and behaviors, contributing to improved earthquake preparedness and mitigation efforts. All the necessary libraries such as pandas, Metro LIV, Seaborn, machine learning tools from scikit-learn and TensorFlow. The earthquake data is loaded from the external source, that is Google Sheets, using pandas read_csv function. We have a screenshot of the code here. Here we can see all the necessary libraries for data analysis that is required to plot and evaluate the data. Regarding exploratory data analysis, it plays a pivotal role to understand the dataset. Here we have checked the first few rows of the dataset using dfhead to get a glimpse of the data structure. Here we can see and observe our data. This is only the few rows of our data. Here we can see only 4 rows. For feature selection, it is a crucial decision in building an effective earthquake magnitude prediction model. For this project, we have chosen the different attributes such as latitude, longitude, depth, number of stations, gap between stations, minimum distance to stations, root mean square, and so on. Here our target is magnitude. We are mostly focused on the determining the magnitude. Also, we have categorized the magnitude into low, medium, and high. Dataset is used to classify the magnitude. We have used the encoder to classify the magnitude, which my friend will discuss later. For further discussion, I would like to hand over to my friend Saugat Pokhrel. Thank you.
Thank you, Newton. I'm Saugat Pokhrel. Now I'll continue the next parts. After defining the target variable, we move on to the data preprocessing. It helps to handle the missing values, encode the categorical variables, and scale the numerical features. In the data processing sections, we have imputed the missing values. These are the null values, which is being done using the scikit-learn's simple imputer. Similarly, the labels are encoded with the categories low, medium, and high using label encoder. Here you can see the code. We have determined the null values inside the data set with the help of code. Then the null values are replaced by their respective column with the help of simple imputer. Similarly, we have categorized the earthquake magnitude as low, medium, and high with the help of label encoder. Finally, the data set is divided into training and testing data sets. 80% of the data are trained, whereas 20% are used for the testing. So here's the code. In the modeling section, we have 4 different models of prediction of earthquake magnitude. Uh, these are distant tree classifier, random forest classifier, native Bayes classifier, multi-layer artificial neural network. Uh, each of the model is trained and evaluated, and their accuracy, precision, and confusion metrics are calculated. Their accuracy and precisions are described later in the another part in detail. So here's the code using the distant tree classifier, uh, random forest classifier. This is the naive Bayes classifier. Here you go, the multi-layer ANN classifier that explained in detail in the last part. So after this, we need to visualize to shed light on the correlation between latitude, longitude gap, and earthquake magnitude. And visualizations are made. So we use scatter plot for the visualization to show any apparent trends or patterns in the data. So from the figure, we can see in the figure between latitude versus magnitude, we can see that the on the farther side of the latitude, higher magnitude earthquake were more common in this farther side. There are higher magnitude earthquakes. Similarly, in the longitude versus magnitude section, we can see that on the farther side of the longitude, higher magnitude earthquakes were more noticeable in this. Similarly, in gap versus magnitude, we can clearly see that the stronger the earthquake, the gap will be smaller. Yeah, the stronger the earthquake and the gap will be smaller. So it's done. So I like to hand over the remaining part to my teammate, Rishi Baskota. Thank you.
My name is Rishi Baskota. My friend Saugat have explained till now. Now I will continue from this part. Here on the figure we can see the graph between correlation heat map and map gap longitude and latitude, and we can see the values of them. Here on this slide, we can see the visualization and correlation. From the graph of the previous slide, we have found out the correlation between latitude and magnitude, and there is extremely weak negative correlation, that is minus 0.002 between latitude and magnitude, and this means that there is almost no relationship between latitude and magnitude, and there is a very weak negative correlation, that is minus 0.005 between longitude and magnitude. Here, similar to latitude, there is almost no meaningful relationship between longitude and magnitude. There is a moderate negative correlation, that is minus 0.434 between the gap and magnitude. This indicates a noticeable relationship between the gap and magnitude, that is when the gap increases, the magnitude tends to decrease, and when the gap decreases, the magnitude tends to increase. In this slide, we will deal with the algorithm and model overview. In this part, we will delve into the strategies and computer models we use to make predictions about earthquake magnitudes, so we can alert people on the time of catastrophic earthquakes. We can think of this as the how and what of our earthquake prediction process. On the step one, we should choose the right algorithms, and we began by selecting different methods or algorithms to teach our computer how to predict earthquake magnitudes. For that, we have used four different approaches. They are decision tree algorithm. We can simply imagine this as a flowchart where the computer follows a path of yes or no questions to reach an answer. And on the second one is random forest algorithm. Here, RFA is like a group of decision trees working together to give a more accurate prediction. And the third one is naive-Bayes algorithm. It's bit like using probability and statistics to make predictions based on past data. And the fourth one is multi-layer neural network algorithm. This is inspired by how our brain work. It's a network of interconnected neurons that learns from the data. And the step two is testing the algorithms. For each of these algorithms, we used our earthquake data to test the computer. We showed it lots of examples, that is test data of earthquakes with their magnitudes, and the computer learned to make predictions by finding patterns in the data. And on the step 3, we are testing our models to make sure our predictions were good and excellent. We needed to test our models. It's like checking if our computer has learned well. We did this by using some earthquake data that it had never seen before, like a surprise test. On this slide, we are dealing with the model performance evaluation testing. Here we are showing the accuracy of four different models. They are decision tree model, which has accuracy of 93%, which is pretty good, and the random forest model's accuracy is 95%, that is far more better than decision tree model, and we have got the accuracy of 93% for naive Bayes model, and finally we have got the accuracy of 95% for the multi-layer neural model. So overall, random forest and multi-layer network accuracy got higher than other models. Here we are showing the numerical values of accuracy, precision, recall, and F1 score, and also the confusion matrix for the four models. And uh, they are depicted on the picture. Thank you. On this slide, we have concluded our project, and the conclusions are: our project achieved accurate earthquake magnitude prediction with high model performance, and the high accuracy rates obtained by our models indicate their reliability and practicability for real-world earthquake prediction scenarios. These models have the potential to save lives and minimize damage by providing early warnings to affected populations. By using various machine learning algorithms, we explored diverse approaches to earthquake magnitude prediction, ensuring robustness. Our findings demonstrate the power of data-driven insights and machine learning techniques in understanding and predicting natural disasters. The earthquake dataset from Kaggle served as a valuable resource, providing comprehensive information for our analysis. The potential applications of our models extend beyond earthquake prediction to various domains that benefit from accurate predictive analytics. Collaboration with scientific research and inspiration from deep learning techniques enriched our project's methodology. Ultimately, our project contributes to the ongoing efforts to enhance disaster preparedness and safety worldwide, emphasizing the significance of data-driven solutions. On this final slide, we have put the references from where we got the knowledges and resources. Therefore, we can successfully complete our project. And the references are the Bilal MA et al. 2022, an early warning symptoms for earthquake prediction from seismic data using fast normalized graph convolution neural networks with attention mechanisms, and Garrick Hogg 2023 Earthquake Exploration and Kaggle, and Biswas 2023 Top 10 Deep Learning Algorithms. Thank you very much.